What is the point of anion gap? First, let's take a look at the equation. It is sodium minus the sum of chloride and bicarbonate. You'll remember from fundamental general chemistry that sodium is a positively charged ion in solution. It's Na plus. Chloride is negative and bicarbonate is negative. So these are anions, these are cations, hence the name anion gap. It just so happens that sodium is the predominant cation in the bloodstream. It is the most plentiful one, and normal levels range from 135 to 145, and let me see if I can remind myself of the milliequivalents per liter. Those are the units for that. But anyway, the reason why this is useful is because different processes result in lack of an anion gap, so which is normal, 6 to 12. This is a non-anion gap if your number is in here. Or it can cause an elevated anion gap. For example, let us say that a person is in respiratory, what would it be? Respiratory alkalosis. So they have low levels of carbon dioxide because they're hyperventilating. If that's been going on for a while, the kidneys can compensate by getting rid of more bicarb. So the level of bicarb will go down from around 25, where it usually sits, to say 17. Now, just think theoretically, and you can pause and write it out if that helps. You'll see that if this number went from 25 down to 17, the gap got bigger for a given sodium level. And you can see just from that, we are starting to think about the underlying physiology, whereas if that hadn't happened, the common thing is looking at anion gap versus non-anion gap, alkalosis or acidosis. Our thought process would go a different way. As a matter of fact, there's this whole list that's sort of codified by the mnemonic mud pilers that helps one remember the differential diagnosis for an elevated anion gap acid-base disturbance. Methanol, uremia, some sort of ketoacidosis, these drugs, phenytoin, formaldehyde, anti-seizure meds, isoniazid, iron can do it, lactic acidosis, ethanol or ethylene glycol toxicity, rhabdomyolysis, and salicylate poisoning. So let's sort of zoom out for a second and think about a real circumstance where that might be useful. Say you have a patient brought into the emergency department with tinnitus, that's ringing in the ears, as well as lethargy, nausea, and confusion. That is you can have a lot of things causing that. So you get a history from her or the person who brought her in. You find out that she has a history of suicide attempts, and that 2 months ago her antidepressive medication was changed. So that should make you think, well, that what could it be on that list? There's a lot of toxicities. We said methanol, we said ethanol, ethylene glycol, and salicylate, aspirin. And so you do a blood panel and you find the elevated anion gap. So you're really thinking about that list, and you also take a measure of the various levels of these toxins. So you take a level for salicylates, which is aspirin is acetylsalicylic acid. So you see that acetylsalicylic acid levels are elevated in the context of an elevated anion gap respiratory alkalosis because she's hyperventilating. And that makes you pretty sure that you've got the diagnosis because that's how it typically presents. The clinical picture makes sense, and then you're able to help the patient out by helping clear that those salicylates out of their bloodstream. So that's just an example of why anion gap matters and what it is. For mathematical examples, calculations, and practice questions, feel free to go online. There are plenty of questions like that you can get for free just using Google. Anion gap is a very, very common topic, very useful in clinical practice as well. Hope that helps.